All right. So we're going to name compounds with functional groups: alcohols, amines, ketones, aldehydes, carboxylic acids, and carboxylic derivatives. All right. You know what all of these are at this point, don't you? Okay. We're going to learn how to name compounds with these functional groups on them. Actually, that's not all the functional groups. There are more than that. Okay. So when we look at the basic structure of the name, we still have the root, right? That's going to be, the root is the longest chain. And if there are any pi bonds in it, you want to include those pi bonds also. Then the suffix is going to indicate whether there is some other functional group attached to it. Right? And we have to identify what those are. Then you still have your prefixes that identify where the substituents are located. So that's the general layout of the name. In order to determine, like if we have a competition, say a molecule has, say it has a carboxylic acid group on one end, and it has an amine group there, and say this one has an aldehyde on the end. In order to determine which one gets to be the suffix, we need an order of importance, an order of priority. Right? So that's where we'll get that on the next slide. It's probably too small to read very well on your printout, but
yeah, it's very small.
It'll blow up on them. So that's why we need the priority, because you may have more than one functional group there, and you have to decide which one gets to be the suffix. Then once you've identified the functional groups and which one is the priority, then you look at the main chain or the ring, and you identify the main chain or the root is the longest chain that incorporates that functional group, that highest priority functional group. Right? So it's got to have that one in it. Then you add the suffix. And each one, it depends on what the suffix is as to what you call it. Then you number the chain or the ring, starting with the suffix. That's the number 1. Add the locator number for the highest priority functional group. Well, that tells me that it might not be number 1. Right, so we'll have to take some examples. Then you add your prefixes and the remaining locator numbers. All right, let's take some examples. Okay, that's still kind of small. Number 1 priority is carboxylic acids. They're always first. So you got something over here attached to that carbon, then you got an oxygen here, and you got a hydroxyl there. That's a carboxylic acid group, and that's number 1. Always number 1. Number 2 is an acid anhydride. All right. This is a derivative of carboxylic acids. So you go here like this, like that. You'd have this oxygen here, and it's think of it as 2 carboxylic acids combined. Right? One coming in this way and one coming in this way. If that's the case, look at it this way. Let's see. Let me draw sort of a mirror image here. Okay. The reason we call it an anhydride is because it's formed by the removal of a water molecule. Right? So you leave that oxygen behind, you take 2 hydrogens and 1 oxygen, that goes off as water. That's the anhydride. And then the bond here forms with that oxygen. There you go. That's probably why this is second priority, because it's derived from a first priority. All right, let's see. I'll put that one back. There we go. So what's the third priority? The third priority is an ester, which is also derived from an acid. An ester looks like this. Let's see. Yeah, that's right. We have some other group out here, carbon-based connection. And then we go like that. So this would be R1 or 2. So an ester is a carbon-based group attached to this oxygen where a hydrogen used to be. That's number 3 priority. Number 4 priority is if you an acid chloride. So if you replace that hydrogen, no, you replace the hydroxyl with a chlorine. That's the acid chloride. The amide, so it looks like we're deriving everything from the highest priority. So the amide now is, we replace that hydroxyl with a nitro group in H2. That's the next priority, number 5. Okay, then we get to the other oddballs. So number 6 is nitrile. So we have this one attached to that one like that. That's a nitrile. Think of hydrogen cyanide. HCN, right? Only we keep the CN part and we attach a carbon to it or some group out here. So if it's got this one on the end of it, that's a nitrile. Okay. Now, if this is the highest priority of all the ones that we have, then the end of the molecule is going to be something nitrile on the end of the molecule. But if it's a prefix, I mean, if it's a lower priority than one of these others, then it's a substituent, and then it's called cyano, right? Derived from cyanide. Okay. So we only call it nitrile when it is the suffix to the name. Let's see. Yeah, I wasn't mentioning that. So what do we call this one? This one's oic acid. Something oic acid. This is oic anhydride. And this is if this would be the suffix for each one. Let's see. Ester. Okay, they're telling us to go to 4A. All right, we'll have to leave that one for now. This would be oil acid. So something like propanoil acid. Amide. Right, this would be something amide. It would be like propanamide if it had 3 carbons and then with the anide, this group on the end. This one, I mentioned this one already. This one would be nitrile if it's the suffix. Seventh priority. And I think I probably should include that table for any tests, because this is something that it takes a while to absorb these
Yeah.
priorities. Let's see. Nitrile. Then 7 is aldehydes. Well, that's this one, this one. Yeah, that's aldehyde. And this would be something al. Like it was propanal. It would be propane with this on the end of it. So we would end the suffix with that one. And then the 8th one is ketone. Ketone is like this carbonyl group, but there's another one on that side, like this, that. So we have an R1 and an R2. So and this would be O-N-E. Then alcohols are pretty low down on the totem pole. And they would end with OLs, right? We know all of these. The different alcohols can have, it can be a terminal alcohol, or it can be somewhere in the middle part of the molecule. It's always an OH somewhere. And then the last one we're given is amines. So N, R, and then some other groups. You can have a primary amine, which would be this one. You can have a secondary amine, which have 2 carbon groups here, or you can have a tertiary amine. See, primary, secondary, tertiary. Yes, you have 3 groups there. You can actually have a quaternary amine if you stick another one on there, but it'll give it a positive charge. But we end the name with amine. It's just. All right. So actually, they're going to the lowest priorities, right? Name the alcohols and amines. So actually, we've done some of this before, haven't we? Propane 1-all,
Yeah,
propane,
because I get confused when we drop the E.
yeah. Propane 2-all. Propane 2-all is isopropanol.
Is that like rubbing alcohol?
Same one, exactly the same. Only it's diluted probably to 70%.
What does that look like? Structurally, like right now?
Um,
Because I was washing my hands in the bathroom the other day and saw a bottle of it, and I was trying to figure it out.
there. 1, 2, 3 carbons, and
Okay.
this is on the 2 carbon. That's propane 2-all. Or isopropanol. Ethanol, of course, would have only 2 carbons with, if we did away with that one, that'd be ethanol. Ethane. And since it doesn't matter whether it's on this one or this one, we don't have to say 1 or 2. Right, just flip it around, it's the same molecule. Cyclohexanol. So cyclohexane with OL on it. And it doesn't matter where it's attached either. We don't have to say 1 or 2 or 3 or 5 or 6. Because if there's only one of them, that's it. Now, what do we do if there's more than one group? Right? Does it tell us that? No, it goes to the amines. I think the convention, say if you have 2 hydroxyls on that ethanol. That's not a good example because there's a special name for that. If you have 2 on the propanol, it's like the propane 1,2-diol. That's the way you would name it if it had two hydroxyls on it. If we went back to this one and we went here. Actually, you wouldn't have to say 1, 2. Because flipping around, it looks the same. So it would just be propane diol. How about amines? Right. If the amine is the only one in there, right? It's the highest priority. Let's see, amines. Amine's the lowest priority. NO2 nitro. Okay, nitro is not going to be a suffix at all. Nitro is always a substituent. Right? Nitro never becomes a suffix to a molecule, to a name. So that being said, the first one, the longest chain with the amine on it is 1, 2, 3, 4, 5 is pentane 3-amine. Okay, so we're still looking for the longest chain as long as it includes that suffix substituent. So I guess we do have to say where it is. Right? What if it were over on that number 4? Then the numbering would switch because you want the smallest numbers. So then it would be pentane 2-amine. Right? If we move the NH2 group over to the 4, we'd have to change the numbering. You'd have to start from the other side of the molecule. So if in the case where that cyclopentane amine, we don't have to say where the amine is because there's only one of them. Now, if there were 2 of them, say there was on 1 and a 2, then we'd have to say cyclopentane 1,2-diamine. Let's see, the next one where we have cyclopentane. Well, nitro has no priority. It's 0 priority. There's no priority at all to nitros. But the amine, of course, then takes the priority. It's cyclopentane amine, and it's on 3-nitro because now, with that, the way the molecule is written, we have to make the suffix number 1. So that means the nitro has to be on number 3. If we numbered the other way around, it'd be 1, 2, 3, 4. That wouldn't work. It has to be 3. Okay, I see some frowns.
I guess I'm confused why 1 isn't like the
Which one?
on C, like what we're
Okay.
talking about the nitro.
Okay,
Like I guess I'm confused why we're naming 3 but not 1 in the name.
for the nitro,
Yeah,
because it refers to where the nitro is located.
I know, but why aren't we naming the 1?
Why aren't we making nitro the 1?
No,
And
like, we
amine
have
the 3?
H2N. So why aren't we putting that in there in the name?
Oh, because it's amine. The amine takes care of that. See right here.
And we don't have to number that? I guess because it's on 1.
Right.
Okay.
If it's on 1, you don't number it.
Okay.
Right. Yeah. Yeah, that's a good point. The last one, chloro's not in here for suffixes, so it has to be a substituent. And the amine group determines the root chain. So it's 1, 2, 3, 4, 5, 6 carbons long. The amine is on the 3 carbon. All right, we start from the side that gives us the smallest number for this suffix. So that's hexane 3-amine. And then we add the chlorine on there. The chloro is on the 6 carbon.
So the suffix always has to come first.
Yes, it has the lowest numbering. Right.
Okay. Because I was confused why one wouldn't start at the right below the chlorine, because that would put that, like it would be lower numbers that way.
Right.
But because the suffix comes first, it's put it through.
Correct.
Okay.
Okay. How about when we have alkenes and alkynes introduced? Well, they don't have a priority. Right. So if you do have one of these groups then they take priority over any double or triple bonds. But the double and triple bonds need to be in the root chain or the root cycle. So that first one, we want to start on the amine is the number one. Now, in this case, why are we saying one amine? Right? Why don't we just say enamine? That doesn't make any sense to me, right? Based on our rules so far, right? Amine's going to be the one. It's going to be number one. So I wouldn't put one amine in there. That's redundant. But that means that we start the numbering so that we get the smallest number. So we have to go counterclockwise in order to get the chlorine in there and the double bond at the same time. So the double bond's going to be a 2 and the chlorine's going to be a 4. But when we write the molecule, C comes before, well, the ene, actually, let's look at it this way. I'm trying to reason this out also. If we just drew this molecule, like that, what would that be? Right, that would be cyclo hex, right? Cyclohex ene. Cyclohexene. There's only got one of them in there. So now if we put the NH2 group in there, the amine cyclohex, and then we're going to have the ene, and then we're going to have the amine. So the amine occurs on one, right? This is one, but I'm not going to put one in there because I don't think it's needed. But now this one is on the 2. So cyclohex 2-ene, amine. Then we add the chlorine on 1, 2, 3, 4. So now we have 4-chloro. And I think the 4-chloro comes out here because of the way the name is structured there. We would always say hexene as part of the parent, rather than saying CH becomes before CY. And that doesn't make any sense. I mean, we have drawn these before with these enes in them, and they're always buried in the name. So I think it needs to stay there, and that means this is left over, and it's just out there. So we still need the smallest number, 1, 2, 3, 4, rather than 1, 4, 6, and 1, 4, 5. That wouldn't work. I hope that makes sense. Okay. So for the second one, we have the all right here, number 9 priority. So we have to say 2 all because we're starting from the side, from the end of the molecule that has the alcohol on it. That's where the numbering starts. So it's 1, 2 all, and then we go over to 4 and 6 for the dienes. So the longest chain is 7, so that's hepta 4,6-diene, and then 2 all. How about let's see. Okay, we don't have anything in there for the triple bond. So we start numbering from the side that gives us the smallest OH number. So that means, and we have to include any double or triple bonds in the parent chain. So that means we have to start from the triple bond side. So that means the all is at 4 and the ine is at 1. I think we do need to say what the ine is in that case. Yeah. Does that make any sense? I hope.
Look at that.
Yeah,
Here we have competition between OH and NH2. So here's competition between these two, and of course the OH wins. The suffix is going to be OL. So, and here again, if OH is on the 1, I don't think we need it. I don't know why they put that 1 in there. I think it should be pentanol. That's it.
that's probably what I would think.
Yeah, pentanol. I'm going to accept that as an answer. And then 5-amino, because we're starting from the OH end numbering. And instead of amine as a suffix, it's amino as a substituent. So 5-amino pentanol. Let's see, what about this other one? This is really complicated. So we've got a cyclohexane, and it's cyclohexanol. Now see, they don't put the 1 in that one. Cyclohexanol. I think they did that one right. Cyclohexanol, because OH resides on the number 1 carbon. And then we number it to the right clockwise so that we get the smallest number. So we're going to have dichloro on 2,2. And then we have amine, diamino on 3,4. And there we are alphabetical, right? DIA comes before DIC. I think that's the way you do it. Or is it Abe comes before C? Maybe that's the way you do it. All right. Let's see. Add the multiplying prefix. Add located numbers. Okay, we've done that. Was this just a reminder, I guess? So we're going to try to name this one. I think I can do that without cheating. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. That one's a double. This one's an all. This one's an amino. And this is another all. That. And then they've got that one. Okay. So the longest chain that includes, what's the priority? We have amino and OH. Amine and OH. So this is going to be amino. This is going to be parent. So how do we number this? Do we start from this end?
We probably want to start with the double
Uh-huh.
bond, won't we? Yeah.
Right. Yeah. So that would be 1, 2, 3, 4, 5, 6, wouldn't it? Because we have to include both of those alls in the parent.
I would assume.
Yeah. So this is going to be hex. It would be hexene, and that would be hex-1-ene. Right? And then 1, 2, 3. And this would be 3, 4, 5, 6, 6 diol. Okay. Then we need to put we have a amino, right? Amino.
Yeah.
We have an amino at 4. I'm not sure where to put it yet, so I'm going to write it down here. 4 amino. And what's this one? This one is 1, 2, 3, 4.
Yeah.
Yes.
4
Is
carbons.
that how you would count it? So would that be butyl?
Yeah. Well,
Or would that be
I don't
isopropyl?
no. Oh,
I don't think I would count that as butyl.
no, because it would be
Is there-
1, 2, 3.
And then there's
be
a methyl.
1, 2, 3, and this methyl.
Yeah,
Methyl off of it too.
Okay, so in parentheses, we would write 5, it's attached at the 5. 1, 2, 3. 2 methyl. 5, 2 methyl. Actually, the 5 comes outside. And inside the parentheses, it's 2 methyl. Prop. There we go. That goes on the inside of the parentheses. So I think amino would come first, alphabetically. All right, I'm skipping out on the side of the board here, so let me see. Let's write it down here. 4 amino. And then this is attached at the 5, right? 5, 2 methyl propyl. Yeah, 2 methyl on the propyl. 4 amino, 5, 2 methyl propyl, X, 1 ene, 3, 6 diol. That's my story, and I'm sticking
you
with
want
it.
me to give you the real one, the answer?
Oh, I didn't get it right. All right. What are they? Let's see.
3 amino, 2 parentheses, 2 methyl propyl. You got that part right. Hex 5 ene 1 4 diol.
Okay, say it again.
So we got 3 amino,
They're saying what? 3
3 amino,
amino.
2, and then parentheses the 2 methyl propyl.
Methyl propyl. Okay.
Hex 5 ene 1 and 4 diol.
Okay. So they need to make 1, 2, 3. Okay. They're starting numbering from here. 1, 2, 3, 4. 1, 4. That gives you the smallest number for the diols. Rather than 3, 6, it's 1, 4. 1, 4 is a smaller number, so we should have started
Oh,
from
okay.
this end. Yeah, I started from the wrong end. 1, 4 diol. And that makes this one 5. 5E. Wait a minute. No.
Hex 5, you put 1.
Oh, sorry. Oh, I'm looking at the wrong one. This is the right one.
Oh, yeah.
1, 4 diol, 5E. Yep. And then 2 methyl propyl. We got that one right. Attached at the 2. Yep. And then 3 amino. Okay. So what messed me up was I started at the wrong end.
Which I would have thought to start there because the double bond.
But apparently what we want is the smallest number available for the suffix.
Yeah.
So 1, 4 is smaller than 3, 6.
I guess the part that's throwing me is the parentheses, like the 2 methyl propyl.
Uh-huh.
Because I would probably, like, I don't know, I would do it differently, I guess.
Okay, let's
So
see.
is it like, because
Where,
me writing it out, it's like completely separate. Like in my mind, I would put it together.
yeah, these, okay. If we just had this one branch, that would be a methyl.
Mhm.
And we just say 2 methyl. 2 methyl. If we branched it, then it'd be 2 ethyl. And if we went further, if we went over here without that one, then we went for at 2, it would be 2 propyl. But if we branch it, then we've got to say what the branch is doing. So the longest chain in the branch is 1, 2, 3. That makes the propyl. And then attached to that propyl is at the 2 position is a methyl group. and then everything is attached, starting with the number 1 is attached at the 2 on the main chain.
Yeah.
That's the only way to reason it out.
I just don't think
You have
to
to treat it
name the
separately.
branch, like I don't think to number the branch separately. Like I would, like if I were to look at it, I'd probably just put 2 methyl or propyl or whatever,
Yeah.
and then not name the, okay. I think I'll understand if I see it.
If we had attached it here to that carbon and not here, then that muddies the waters. And forget I said anything. I'm making it more complicated than it needs to be. Okay. All right, so there you have the idea of the primary amine. Here, this is a primary amine. Secondary amine has another carbon group down here. Tertiary amine has another carbon group up here. Let's see. Which alkyl group attached to the nitrogen establishes the root? You have to define that by the longest chain attached to it. Now, I don't think they're saying that becomes part of the name, though. Right? That's just identifying whether the amine is primary, secondary, or tertiary. We don't add that to the name. We don't say primary, blah, blah, blah. Okay. Let's see. I've got something covered up here at the end. Okay. More examples of alkyl groups attached to the amine nitrogen. All right, when we have this one and we have attachments to the amine group, this is how you name it. Right? In the examples we had before, the amine group only had attached at one point to the rest of the molecule. But if you have something else attached to the amine, then you want to say what it is. Right? So in this first example, we've got a methyl group attached to the amine on one side. We have do like that. We have a methyl group attached to that side, and we have a cyclohexene attached to the other side. Right, and the double bond is here. All right. So the cyclohex, here we have again, what would this be? This would be a cyclohexene.
Yeah.
Cyclohex.
Well, it's saying 3E.
3E, yeah, because this is the number 1. This is 2, this is 3. So hex 3E. Okay, we know that much. Okay, then we want to say that amine group, again, I want to say just this, because that has to be the number 1, attached to the number 1.
Why wouldn't the amine come before the E?
Oh, because this is the high priority. It always comes as the suffix at the end.
That's right. Okay. I keep wanting to put it in like numerical and alphabetical order.
Now that we have this methyl group attached to that amine, we have to say what it is. And we want to, since this is the root. That whole thing is the root. So that means we're left with a methyl group. And where's the methyl group attached? It's attached to the nitrogen. N-methyl is attached to the nitrogen. Right. So this prefix, there's no competition. This prefix is all by itself outside the root. I consider this whole thing the root now. And it's easier for me to understand if I say this is the root and then everything else is substituent prefixes. Rather than saying, well, there's no other way to approach it, I don't think. Because this is the longest chain right here with that in it. So that has to be the root. Okay?
Yeah.
All right. Let's see, what about this second one? 1, 2, 3, 4, 5 carbons in OCA. 1, 2, 3, 4, 5 carbons, and then a methoxy, right? That's what we call that, methoxy. And then this one is attached to a nitrogen. And on it is methyl and an ethyl. Well, this is a tertiary amine. All right, the longest chain with that attached to it is here.
You're
One.
forgetting the methyl group on 3.
Is there a methyl? Oh, sorry. Methyl, there's 3, 4, 5. So this is a pentane. Pentane, and the amine is attached at the 2. Right? And then we have 2 substituents. We have a methoxy attached at the 5. Methoxy attached at the 5. And we have the amine group. Let's see, we have a methyl and an ethyl on that nitrogen. So hold on a second. Why is it? Oh. I forgot that methyl on the 3 group. 3-dimethyl pentane. There are 2 methyl groups. Yeah. There are 2 methyl groups. All right, so we have this methyl group and we have this methyl group. So we have this one doesn't have a number because it's the suffix. So we have to say this is attached, one of them is attached to the N and one of them attached to the 3 carbon. Dimethyl. Okay. And then we have the methoxy, which is attached, excuse me, I forgot the ethyl. Where's the methoxy? We have to do it in alphabetical order though. Now, why did they put? Are we saying that whenever we have, okay. All right, that I'm stumped. Why do we separate the ends?
That's what I'm confused about, the ends in general.
Yeah. We got a dimethyl here, but I'm saying, why do they put that one here and not before? Right, and we have the N-ethyl out here. Okay, I'm running out of room. We have the N-ethyl. I know N-ethyl has to be in there because that's what that one. And I know 5-methoxy has to be in there. But what order are they? Right, which one comes first? Right, is the M-ethyl or the 5-methoxy? Right, I guess E comes before M. Right, that makes sense. But why does the dimethyl come after the M? I don't know. I'll try not to give you one like that on a test. Because if it confuses me, I can't expect you to get it. All right, let's move on before I run out of time. and can't get to the labs. All right, it's already 12 o'clock. All right. Ketones and aldehydes. Okay, where are they located? Here's the ones. Here's the alds. So that's the general form for a ketone versus an aldehyde. Actually, an aldehyde doesn't have to have a carbon attached here. This can be this can be a hydrogen. If that's a hydrogen, what do we have? Well, the IUPAC naming for this one would start with, what would we start with? Right, one carbon would be, the methane would be the beginning, would be the root. Methane, not al. Right, methanal. That's what that is. But the common name, you probably recognized, formaldehyde. That's formaldehyde. This would be a trivial name. This would be the IUPAC name, methanal. Let's see.
When we talk about ketone, like, is that like the same stuff that's in our urine? Or is that completely different?
If you're diabetic,
Yeah,
yeah,
okay,
it's the same type of molecule. There are several ketones that are excreted for a person that's in acidosis.
yeah.
Yeah, but it's the same molecular structure. It has that.
Now, don't you also let off ketones when you're on a keto diet?
Yeah, probably. Yeah.
Because because I know you can buy strips if you're on a keto diet
Mhm.
and you urine test the strips. So I'm
Yes.
assuming that's the same thing they're testing for.
Yes. Mhm.
Okay,
Yeah, I've got some in my house. My wife's diabetic.
yeah.
We've never had to use them. Acetone is the trivial name for propanone. So that has a carbon here, has a methyl group here and a methyl group there. That's a ketone. Propanone. All right. If you have an alcohol and a ketone together, that means alcohol takes precedence over the ketone takes precedence over the alcohol. So that one with 5 carbons, 3, 4, 5, and one of them has carbonyl and the other one has an alcohol, then you would, as long as you've got the alcohol in the root, right? We would start numbering from here. 1, 2, 3, 4, 5.
It has the other one.
Why?
I guess because ketones are higher priority. Right?
Oh, you're right. What am I thinking? I'm not thinking. Yeah, right. You would start from this end. From the higher priority end. Yeah.
But in the name, it doesn't have the OL. So I'm confused as to why there's an alcohol group, but we're not naming the alcohol group.
Oh, okay. So we have 5, so it'd be pentane would be the start, and then we'd say pentanone. So it would be a 2-pentanone, right?
Yeah.
Pentane 2-one, excuse me. There we go. That's the one on the 2. And then where's the OH? Well, it's not an all anymore. Right.
Oh, it's
Because this is priority. So that would be a hydroxy.
so
it'd
you
be-
prefix.
Right.
Okay.
Before hydroxy. Pentane 2-one.
So how do we know which one's going to be the prefix and which one's going to be the suffix?
Priority.
Okay.
This is higher priority, so it's the suffix.
Okay. I would think it'd be the other way around. Like pre being first and then however already being first. I don't know. That's just the way I think.
Sorry. Never gonna happen. Where'd I hear that? That's in a movie. I think William Devane said it in one of his movies. Never gonna happen. I'll think of it later. Won't waste class time trying to remember a movie. Okay, so they can get ridiculously complex. That last one, cyclohexane has 3 keto groups on it. That's also referred to as a carbonyl when you have a carbon and a double bond O. So when I say carbonyl, that's what I mean. It's a carbon with a double bond O on it. This has 3 carbonyls. So we have 1, 2, and 4 trione. All right. For the aldehydes, we never say the number for the al because it's always on the terminal carbon. It's always on the number 1 carbon, so we just don't say 1 al. It's always just butanal for our first one. Butyraldehyde, that's an older name. Butyraldehyde is now that's relegated to trivial names. Some are kinder and call it common names, but I think the proper terminology is trivial. Butanal. So aldehyde takes priority over ketones. So that's why the next one is pentanal. And then the oxo references this one. Oxo is on the 3 carbon. Okay. In the interest of time, I'm going to skip those and let you practice them with homework. What's next? Naming. Oh, it's all covered up. There we go. Carboxylic acids, acid chlorides, amides, and nitriles. All right. So the highest priority is carboxylic acid. If you've got a carboxylic acid there, you know you're starting there. Right. So the name is going to be oic acid on the end, always. If you've got carboxylic acid group, which will be always at the end. Right. So it doesn't get a number either. If it's oic acid, that's always on the end of the molecule. So that first example, what's the longest one that has the oic acid? It also has the double bond, and it's the longest chain, right? It's the decane would be the longest chain. And we have, if we start numbering from the oic acid side, then the number 2 carbon houses the double bond. So it's 2-ene oic acid. And then, of course, the dec to begin with. And then where does the oxo reside? Oxo resides on the 9. Now, here's the thing. This has a stereochemistry, right? Because of that double bond, right? This is going to be the way it's written, right? That long group, let's see, should I write it out? One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Well, I got it upside down. Let's try it again. Let's be consistent with there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Okay, this one has a carbonyl on it. Double bond is on the 2. That's 1. This is, oh, there's the OIC part. This is the 1, this is 2. There's a double bond there. Okay. Now, why is this one E isomer? Because the way it's written, this group is on the opposite side of that group. Right, it's on the opposite side. So this is E. It's the E isomer with this is 9, so that's 9-oxo. So we have E isomer of 9-oxo dec 2 ene oic acid. Okay. That one's fairly straightforward. I'm glad they brought that out though, to put that E there. Now, the next one has a chiral carbonate too. So in that one, we have to decide whether it's S or R. Right? Is it rectus or sinister? First thing you do before you decide whether it's S or R or E or Z, name the whole molecule first, and then you put the stereochemistry at the beginning. Well, actually, you put the stereochemistry for the carbon that you're numbered. Right. Since we only have one for that first molecule, we only have one double bond in there. So when we put E in there, we know what it's referencing. By the number 2, or like E dec 2 enoic acid. I have to go back and look at the conventions for the EZ, because I think when we say R or S, we put that where the carbon is. So that R2 references the number 2 carbon position is the chiral carbon. So first of all, is that carbon chiral? Right, look at what's attached to it. Well, the hydrogen's not showing, but it's also attached to a 1, 2, 3, 4, 5 to a pentyl group is not dash, but what's the other one? Dash wedge. Thank you. Some days are like that. So that means it's coming out at us. And that means the hydrogen has to be behind. So the hydrogen's already behind. What we need to do now is decide what's the priority. Right. So why don't we draw it? Rather than try to talk about the slide. So we have 4, starting from here, that, like that. And this one has, on that end, it also has one on this end. And so it's dioic acid. And this is butane. So which end do we start from?
The alcohol group on the right.
Yeah. Now, why didn't we start from the other end? 1, 2, 3, because that'd give us a larger number, right? For that pentyl side group. Yeah. So we started from the right. Okay. So the pentyl is on the 2. And let's see, we're going to put like that, and that carbon then is attached to that, right? 1, 2, 3, 4, 5. Okay, we know this hydrogen is in the back because this one's in the front. So since that one's in the back, that's good. Now all we have to do is say, what's the priority? Well, say, okay, if we go to this carbon, this carbon, this carbon, now we need a tiebreaker. So what's the tiebreaker? This is 4 priority. So if we go to that carbon, that carbon, that carbon, then we have to go to the next one. There's another carbon, there's an oxygen. Actually, there are 3 oxygens, right? A double bond counts as 3. So this one is the highest priority. That's 1. Okay. What's the next priority? Well, if we go to this one, then we go to that carbon, we go to this oxygen. This is the next priority, this group. And then this is the last priority. So with that in the back, 1, 2, 3, we're going to the right, rectus. That's why it's R. Okay. Now, if this had been dashed and that had been wedged, thank you. I would still count it and say, okay, if we count it this way like that, then when we put that in the back, that becomes S. That's the easiest way to do it. Just go ahead and set your priorities with hydrogen in the front and then just reverse it.
Now, with the name.
Yep.
They don't number the dioic, and I don't understand why. Like, why wouldn't they put 1 and 4 dioic?
Oh, because the carboxylic acids are always on terminal carbons. So if we know that it's a butane structure and it's dioic, that means you got to have 1 oic on one end, 1 oic on the other end. Can't be in between.
Okay.
Yeah. And in fact, I don't know of any trioics. Oh, I guess you could. If you had a branched molecule, right? You can have trioic. Like if you had, let's see, that, and we had there, and we had there and there, and we had, let's say, had another carbon here, and then that had like this. That would be a trioic. That would work. But let's see, I'm going to have to fly back to the thing and see what if the oic is if the oic is a prefix, right? We can say oic here and oic here, but this would be part of the branch, right? This would be maybe 1, 2 carboxy. So this would be dioic. It would be a trioic acid, but the naming convention would be dioic for the suffix, and then this would be like a 2 carboxy on that 1, 2, 1, 3, 4 on that butanoic. It'd be butane dioic acid with a 2 carboxy prefix. Go figure. Let's see. Okay, that's where we were. All right. Let's see. Okay, we did those. Nitriles. So the nitrile is here. And it's 6 priority. Is there anything else there? No. So the nitrile doesn't have to compete. Oh, except on the first one, it doesn't have to compete. So it's hexane nitrile on the end. And then cyclopentyl is a side group. All right. For the second one, though, we have a competition between oil acid. So the propane, 1, 2, 3 carbon. Now, why didn't we count the carbon on the nitrile? Right, the first one, we start with a nitrile. Oh, because cyano is now going to be a substituent. So we start from the oil chloride side. That's number one carbon. Right, let's see. 3.
How are we gonna know that though? Because I would number that, just looking at it. Like, how are we gonna know that that is a substituent?
Okay, priorities. The priority for this is here. And it has a higher priority than this one. It's a 4 and this one's a 6. Right, so when that happens, we have to start numbering here. 2, 3. And then the nitrile becomes a substituent. So this is a substituent. The parent chain or the root is only 3 carbons long. And it's because this has higher priority. Now this becomes a substituent.
Okay.
Yeah.
I'm not really getting it, but that's okay. I probably won't.
Well,
Because on the first one, we
Well-
number the carbon on the triple bond. So I guess I'm not understanding why this one's not and it's a substituent
Oh.
instead.
when that's the only one in there,
Yeah,
right, it's not competing with anything else. So it's the nitrile suffix. And the suffix always starts on its first carbon.
Yeah.
So that's why this would be 1, 2, 3, 4.
Yeah.
But when it loses in the competition with this one, then it becomes a substituent. And now the root chain is only 3 carbons long,
okay.
and the substituent has a carbon in it. Don't think of it as a carbon as part of the chain. This carbon is a substituent.
Okay.
All right. Amides. Okay. Amides. Here we go. Amides. So amides are also going to occur at the end of the molecule. They're always terminal. Well, okay. Yeah. If the amide wins the competition, it's always terminal. So the first one, it has no competition with anything else. All right, this amide starts at the number 1 carbon. But the amide itself has attachments to the end. All right, so the amide, where was I? Here. This is a primary amide. If you have a secondary amide, then you have to say what's attached to it. That's why when we say amide on that first one, we also have to say there's an N-ethyl and an N-methyl attached to it. And then it's 7 carbons long, and it has an ine group at the 3. All right. The second one is a little more complicated. In that case, the oic acid wins, and that means the amide has to be, we have to give the amide its suffix name. So I've got to go back because I don't have that memorized either. Here it is. So where's the amide? Amide's here. Carbam oil. Right, so carbam oil is its substituent name. Let's see. Yeah, I'm on the right one. So the carbam oil is now not high priority because the oic acid is there. So that means the carbam oil has to be attached to that number 2 carbon. And this is another dioic acid. All right. I'm not sure we have time to do this one. This one is going to require some stereochemistry, I think, right? Because those are 4 different groups. The hydrogen is not shown, but we have an amine group on one side, we have a carbamoyl group on the other side, and we have a carboxylic acid. So the carboxylic takes priority. Right, it has one, let's see, 1, 2, 3. Yeah, 3. And the carbamoyl is on the 3 carbon. The amino is on the 2 carbon, and the carboxylic acid starts the chain. So let's see. That's a carbamoyl. Okay, I see that. Where's the name? Didn't give the name.
Yes.
Oh, it's in the bottom. There it is. 2 amino. Okay, got that right. 2 carbamoyl. 3 carbamoyl. Oh, they didn't give stereochemistry. They're not being consistent. There is stereochemistry with this molecule. Right? The hydrogen's facing forwards. So, oh, we don't have signs. Sorry. We'll have to skip that for now. Carboxylic acid derivatives on a ring structure. Okay. So we have to include both the ring and the functional group in the root name. So that first one, cyclohexane carboxylic acid. Why don't we say cyclohexane oic acid? Because we don't. I mean, there's no rhyme or reason to it, really. They just have to decide this is the way we're going to do it, and everybody else has to learn it. So instead of saying oic acid, when you have when the carboxyl is the highest priority and it's on a ring structure, we actually say the whole carboxylic acid. And I think the reason we say that is because in a straight chain, say like this, where we have like that, that carbon is in the chain. But when we have a ring structure like this, that carbon is outside the chain. So that's why we name that carboxylic acid. So it's cyclohexane carboxylic acid. That means it's actually 7 carbons. But when we name this one as 1, 2, 3, 4 butanoic acid, we know that's only 4 carbons. That's the only thing that makes sense. And then, of course, we're going to add a 3-oxo one there. What if we have an amide on there? Carboxamide. Okay, so instead of saying just straight amide, we're going to say carbox. And I think the reason we're saying carbox on there rather than oic acid or amide, just pure, when you have a cyclic group, that carbon is outside the ring. So we add the carbox to signify that that carbox is outside the ring. And then carbonitrile, same reason. I hope that makes sense. It's the only thing that makes sense to me. Esters and acid anhydrides. All right. An ester is has a carbon-based group attached to that oxygen on the acid. So this is going to be naming convention. Okay. In order to define the ester, we have the parent chain with the carboxylic acid, the previous carboxylic acid, and then we take the group that's attached in place of that hydrogen and take that name and add OATE on the end of it. So for our first example here, if we have a butane, if we were like this, 1, 2, 3, 4, that would be butanoic acid, wouldn't it? Okay. If we make an ester out of it, and say we add 1, 2, 3, we had 3 carbons on it. So that would be propane by itself. But when we add it to the molecule, it's propanoate. So we would start off with this actually, this becomes a prefix, I think. No. Yeah, full. Sorry, my mistake. The O8 comes from this part of the molecule. That makes more sense. Butanoate is the parent or the root. And then this is 1, 2, 3. This is propyl. Okay. Hope I didn't confuse you. I started to confuse myself. So when we have an ester, we start with the part of the molecule that has the acid, the carboxylic acid in it to begin with. And then when we attach this group here, it becomes a prefix. So propylbutanoate says that this butanoic acid now, instead of butanoic acid, now it's a butanoate because we've added something to that position. So far, so good. All right. And it's going to get complicated. Right. So let's see. If we look at this one, we see the highest priority is what used to be this carboxylic acid group right there at 1. I'm circling it there with my cursor. So that means we're talking about butanoic acid, but now we're making an ester out of it. So we're going to have a group attached to that oxygen, and we have to decide what to call that group. So it's at the 1 methyl position, at the 1 carbon on the propyl, you have a methyl attached to it. So 1 methyl propyl. I guess we don't need parentheses because it's all a compact name. And it's a butanoate because it's an ester. And then we also have at the 3 carbon oxo. So in that case, we do put them in alphabetical order. M comes before O. Now this one has stereochemistry involved. And here we do say, if it's S or R, we have to say which carbon is we're referencing, in addition to which carbons have the hydroxys on them. Right. And we have esterified this molecule with a phenyl group. Right. Phenyl is just the benzene ring. Right. Benzyl's the one if you have an extra carbon on it. So if we said benzyl, then we'd have a carbon there before you get to the phenyl ring. All right. I'm going to have to skip this, otherwise we're going to run out of time, I think. How many more slides do I have?
2,
Oh,
once we name that one.
oh, once we finish with this one, we got 2 more slides?
Yeah.
All right. So let's just say, where would we start with this one? Well, we start with the, here, the ester. Oh, I didn't write that either, did I? This is the O8. Skip that one. So that's the one we would start with. This would be, and since the nitrile, again, is a substituent, we don't count it as one of the carbons. Right? So the carbon on that molecule, where we start numbering, is this, and then this cyclopentane. All right, so this is number one. Yeah, this is number two. This has a hydroxyl on it. And this has the nitrile. So we start numbering from this side. And this nitrile is attached to the 3 carbon. This is cyclopentyl. Cyclopentyl. I'm not sure if it comes first yet. And then this is 1, 2, 3 propanoate. Okay, for that part. And then we have this hydroxy on the 3. So 3 high will come after that, I think. No, we need the nitrile. Nitrile is on the 3, and the hydroxy is on the 3. So the H nitrile, that comes first. So this would be 3 hydroxy and 3 not nitrile, but cyano. 3 cyano cyclopentyl propanoate. Let's see if I got it right.
It has a steric in it though.
Yeah. Oh, they want us to do the steric. Okay. So if our hydrogen's facing back, now we all need priorities, right? That's a carbon, that's a carbon, that's an oxygen. That's number 1. And this is number 4. So we have to decide which one is what. This carbon attached to a nitrogen, carbon attached to another carbon. Nitrogen has a higher. No, oxygen has a higher number than nitrogen.
Yeah,
So here. Oh, but it's higher than carbon. All right, so this one's this one's 2. That makes this one 3. So it's 1, 2, 3. So the left is sinister, right? So that's an S. S on the 3. So what do we say? We say 3S.
it's cyclopentyl S 3 cyano 3 hydroxypropanoate, or however you say that.
Propanoate.
Yeah, propanoate.
S. Oh, name is cyclopentyl S3. Cyclopentyl. Now, why did it do that? Well, S is on the 3. I don't know why they put that first. Why didn't they put the stereochemistry first? Like, go figure. I had no clue. Acid anhydrides. All right. So since the acid anhydride is the product of a bonding of 2 carboxylic acids, we have to base the name upon those carboxylic acids, I think. So if we say, if the acid anhydride is unsymmetric, then name the molecule according to the general form alkanoic anhydride. All right, so if we say this is a symmetrical alkanoic, all right, oic anhydride, this would be 1, 2. So there'd be ethanoic anhydride. Ethanoic means, or is it diethanoic? Let me see. Propanoic anhydride? Okay, so if it's symmetrical, you only have to name one side because the other side's exactly the same. So if this one is ethanoic, we say ethanoic anhydride. That means that we have two ethanoic acids that have been bonded through an dehydration synthesis. But if they're different, then we say for the second one, there's a benzoic acid and an ethanoic acid bonded together. And we put them in the order, alphabetical order. So B comes before E. That one's fairly simple, I think. Oh, that's it.